Hi, welcome to this video presentation on my project, the Portfolio Optimizer. This project combines classical financial theory with modern machine learning. We will explore how predictive models and statistical indicators and optimization algorithms can be integrated into a single tool that would help investors or retail investors to make decisions in the market. Okay. Uh, First, we'll be talking about the motivation and the problem statement of this project. Financial markets today are more complex and volatile. Traditional portfolio strategies like mean variance optimization often fall short in responding to rapid market changes. On the other hand, machine learning models bring adaptability but often lack transparency. The question was, can we combine the best of both worlds to build an intelligent, explainable, and customizable portfolio optimization platform? Okay, so I'll go into the technologies used uh, in this project. Then I would do a short demo. Okay, in building this project, we used obviously Python, and we used LSTM, long short-term memory, ARIMA, Profit, and XGBoost, and many other models. These models are trained on historical data with technical indicators like MACD, RSI, and Bollinger Bands. Optimization is done through classical models like Markowitz MVO and hierarchical risk parity, combined with heuristic like genetic algorithms. It's an algorithm that is not really related, but I got the inspiration from it. Okay, this interface was built through Streamlit, offering real-time interaction with the market and and portfolio recommendations through the machine learning algorithm. Okay, so right here, you can see we can enter symbols, symbol of the stock, for example. So let's try to explore the market through different symbols. Uh, I will pull up, let's say, random symbols, and we'll see the price history and everything about it. Okay, so this is a random stock. Let's see if it has enough data points to be able to be analyzed. Okay, this is BEN, Franklin Resource Incorporated. It's in the New York Stock Exchange. This is the price of it, $17.72 as of today and the recording. And over here we can see the price history. We can obviously move the price history as far as we can from 30 days to 10 years. Let's say I would aim around 5 years of history. Okay, and let's say I would increase also the forecast horizon. Let's say to around 180 days. Okay, so basically, right now we can see the price, and then we can see the predicted price or the price forecast as the dotted line. This uses the ARIMA and Profit um, algorithms, and we can see also uh, we can see the red hue is the range of the price. Obviously, it gets bigger as time goes by because of the unpredictability, the nature of the market itself. Okay, And over here we have some other indicators. Obviously the RSI to see the relative strength index to see whether the stock is oversold or underbought, and the MACD also to see it's basically a histogram to see we compare between the actual signal and the MACD. Okay, here we're going through the profit forecast details. This is one of the algorithms that were used to forecast mainly in the graph above. Over here we can see the 7-day and 30-day forecast and 90-day forecast. We can see the trend analysis. We can see weekly patterns and seasonal analysis. These three analyses are for short, medium, and long term. And then we can see over here the possible scenarios. Obviously, these scenarios are basically trained upon the historical data and and also trained on the general market index. This stock does not have any like news. Or it probably have news, but not very significant. Okay, over here is the model configuration. This is where the NVO comes in, where we can basically balance the weights or like tip the weights from one algorithm to the other to see uh, to see which configuration works best with the stock. So, for example, because this stock is not very known, I would basically be inclined to use volatility focused. Yeah, over here is a recommendation best for small cap stocks and emerging market stocks and crypto related stocks. And then it would train the models to in a it would train 5 models, and these models would predict the price of the stock in a month's time, and it would give you the ensemble price, which is the aggregated price. Right here, it would give you uh, every model and their predicted price in the target date, which is in a month's time, for example, and it would give you the deviation. So SVR was the only model that predicted a, a a increase of a substantial increase of the stock of $1.25. Random forest is an increase of a cent, which is relatively flat, and others too, which does not have any really significant decrease of the stock. And then here we have the model consensus analysis, which would aggregate all of the 5 models decision, and then it would give you like one one decision, or it would unify their decision. Sorry. Okay. Okay. A this was to show how a small stock would perform. It's not the optimal stock, but it is a random stock to show the capability of the program, and that all of the data has been taken from Yahoo Finance and could be taken from the, let's say, the smallest to the largest stock in the American market. Okay, now I've added 2 other modes into the program, uh, which is one of them is the stock comparison mode, and the other is the backtesting mode. The stock comparison mode is basically the closest thing to building, let's say, a portfolio, so I can compare the stocks to each other and their metrics. Over here, let's say we can increase or decrease the days of comparison, and we can also add the metrics that we want to compare. Over here we have a very basic comparison between Apple and Microsoft and Google. Over here is the normalized price, which is basically it is a scale from 0 to 100% and their increase or decrease despite of price. And over here is the trading volume. It just compares the metrics. For example, the trading volume over here, the volatility, and it gives you the volatility ratio and the volatility percentage. The RSI, it would also give you a correlation matrix. Let's also add the MACD because it's also a very important metric for short-term investors. And over here it would give you the Sharpe ratio and the annualized returns and the annualized risk. Okay, this is a quick overview of the stock comparison mode. Now let's go to the backtesting mode. Let's say I would choose one of these models to backtest with. Let's say I would choose Random Forest, and I would like to increase the data points for accuracy. Okay, over here, the first price point, it would give you the predicted price versus the actual price. Obviously, it would give you in a past date because it's backtesting. So here it would give you the predicted price versus the actual price on the 1st of January 2024, which is last year. And then here it would give you the error, the error percentage. And here are other metrics. Basically, the root mean square, the accuracy. And here at the end, it's a small trading simulation. I found through consistent testing that the Random Forest had the most consistent returns and direction accuracy, which would directly correlate with the returns. Over here is a price action history. It would show like it would basically simulate when it would buy, when it would buy, and when it would sell the stocks. And yeah, you can see here it did around 15 trades, and the total return was around 6.92%. This is the buy and hold return if you just bought and held, and the strategy return is 16.61%. And over here there's the model evaluation. Obviously, the model would struggle with the price prediction direction because it is not trained with much information compared to professional trading algorithms. Yep. Okay. Thank you for watching the video. Hopefully you liked it. Thank you.